Well, hello. It's actually one of the first experiments about me looking at some of the tools that are very interesting solution, which is utilizing natural language to generate SQL for any data source or relational, non-relational, as long as it accepts the declarative language of SQL. I saw a really interesting article from Uber and about a new tool that they introduced, and I would like to go through it with you guys. The tool is called QueryGPT. So it's QueryGPT natural language to SQL using generative AI. That's on Uber's engineering blog. So it goes through the introduction. We know that declarative languages, the beauty of it is since it could sit on top of any data source that can translate these statements that you write with SQL to actually some data source to grab or query data and pull whatever information that you need from that data source. So the beauty of it has always been like that abstract layer that declarative language makes, where as long as your data sources start supporting this kind of language, it's gonna be all you need to pull the data that you want. So now there is another layer, which is large language models that come in. I can, with natural language, just say or type English, and it will be translated to a standardized declarative language like SQL, and then you go ahead and you just execute that just like in on any data source, like a relational database or non-relational if it supports SQL. QueryGPT uses large language models, vector databases, similarity search to generate complex queries for the English questions that are provided by users as input. So they're saying that they went through a couple of phases. One of them is the hack days version 1. The user prompts the system in English. It goes through some SQL samples and schema samples with similarity search to find if there is a query with the same uh, context. This is like an example of the sample of data that they have. It generates a query. System prompts SQL samples, tables, instructions, goes to OpenAI GPT and generates a SQL query and explanation. And once it comes back, it runs it through the data. I guess that's like the simple. So it's a simple RAG implementation in this case. They mention here that they actually included some of the lingo inside Uber. So this is an example where it comes back given to answer this question, an explanation of why it did that, and then the LLM provides the SQL query depending on the context that was provided. Then they go through a flavor of better RAG. So they had an issue where it wasn't returning a lot of relevant results, even with the simple architecture that we talked about in the beginning. But then another issue that was found is that after the simple architecture was set up in place, and other than it wasn't returning relevant results all the time, what they faced is that between what the prompt is that the user provides and what the data schema is, they felt that there has to be an intermediate solution that sits in the middle and identifies what the intent of the user is so it can actually choose the right data schema that it needs to take a look at. Now, QueryGPT got bigger. So now from the simple architecture that we looked at, now it got more advanced. So now this is the intermediate step that they were talking about. Natural language prompt comes from the customer or the user. It goes through an intent agent, which identifies what is the intent of the user. In other words, even if I'm talking about I want the users, do I want internal users? Do I want users as customers? Examples of that could be the definition of a transaction. As much as you hope that there is some kind of unity when it comes to naming conventions, but there could be a definition that is different from one system to another, one department to another. So the intent agent is going to go get workspace and SQL tables depending on the intent, and then generate some SQL samples. And then there is another agent that handles the tables and then gets the table schemas, metadata gateway, gets schema details, and then there's a column prune agent, which Uber mentioned they have tables that sometimes span to 200 columns, and I'm sure in most of the cases where you need to query data, you don't need all the columns. So, and putting into consideration also that if you want large language models that are hosted by you or that are externally hosted, there is a context window limitation. So imagine if you have 200 columns, that's a lot of definition to pass to some large language models. And there's still a challenge with large language models where even though the context window is huge, that doesn't mean that it reasons everything in that context. So it needs to be very optimized so you can get the maximum benefit. So a column prune agent apparently chooses which columns are the most important for the query, then custom instructions, and then it generates the query. Gen AI gateway that goes to Azure OpenAI, apparently like they use something already, a SaaS or in Azure, and then comes back Gen AI gateway, and then it passes the explanation and the query. In our design, we introduced workspaces, which are curated collections of SQL samples and tables tailored to specific business domains such as ads, mobility, and core services. Just like we mentioned, different entities can mean different things to different teams and people, and that's an example of it where the business domains, just like ads, mobility, and core services, have Uber introduced workspaces to actually have certain collections of SQL samples and tables depending on the business domain, which is smart. Mobility is one of these system workspaces that they identified as a foundational domain that could be used for query generation in general, which is like trips, drivers, document details. So some of the examples are write a query to find the number of trips that were completed by Teslas in Seattle yesterday. Now that's a breakdown right now of the agents. So this is an interesting one as we were mentioning, is that instead of just throwing whatever like the user has as a prompt and hoping for the best that it's going to catch whatever the data schema that is needed to tackle the SQL query, the idea is to shrink it as much as possible because that optimizes the work of RAG. Because the idea overall is the user prompts, I generate some context or I find context that is very useful that I can pass to the large language model with my prompt so I can get the best results. If I'm throwing at it like everything, every generic data schema out there or every generic SQL query out there, that's going to actually give it a higher probability to hallucinate. So you're trying as much as possible to ground the answer, ground the response, the inference from that language model as much as possible. So the intent agent comes here to optimize. Then they have a table agent, allowing users to select the tables used in the query generation came up as a feedback from some users who saw that tables that were eventually picked up by QueryGPT were not correct. To address this feedback, we added another LLM agent that would pick the right tables and send those out to the user to either acknowledge or edit given the list and set the right tables. A screenshot of what the user would see is shown. So that's interesting because this table agent is actually a pure example of human in a loop. So the idea is that they got feedback from Uber users saying like, okay, I tried to say, show me all the trips from Tesla drivers in Seattle yesterday, and they're finding out ways because again large language models hallucinate and you should always confirm what you get back. So the intent agent actually tried to optimize as much as possible where the business domain is that this person is asking about, but at the same time the table agent is saying, okay, I think from the data schema that I got from the SQL samples that I got, SQL queries samples that I got, these are the tables that I should be looking at to actually generate this query. But then Uber, depending on the feedback from the user, said, okay, I'm going to inject human in the loop right here, where after this table agent is finished, it asks the user, do you believe those tables are the ones that you should be looking at? And the user can correct, approve, decline, and then confirm that all the tables that are needed before it goes to the next step, which is pretty cool. You can see an example where that's the bot, and then that's the user prompting it, saying, this is what I need. Again, we talked about the intent agent that knows exactly which domain, business domain that it needs to look at, so it gets the right or the collection of data schemas and SQL queries. And then the chatbot comes back, which is the table one, the table agent saying like, okay, I'm planning to use the tables below to generate the query. What do you think? Now the user has the ability to say, yes, looks good, doesn't look good, corrects it, or declines what the agent is asking for. Now we have a third column prune agent, another interesting one, which is we ran into another rolling query GPT out to a larger set of users was the intermittent token size issue during query generation for some requests. We were using the OpenAI GPT-4 Turbo model with 128K token limit, but we're still seeing token limit issues because some requests included one or more tables that each consumed a large amount of tokens. To address this issue was implemented a column prune agent where we use an LLM call to prune the irrelevant columns from the schemas we provided to LLM. All right, so now we introduce a third agent, which is the column prune agent. And this one, I believe, is the same concept as the intent agent, which is the idea of it is to choose and optimize. To choose and optimize like what's best to move forward. So what it does is like there's a lot of tables. You have a limitation on the context window from large language models, whatever you use. And in their example, we're using GPT-4 Turbo, which was a 128K token limit. And that's a hard limit. That's going to stop your operation if you don't prepare for it in your application, where you can actually have a fallback or split it in type of way, which maybe it doesn't serve the purpose of this tool. So the idea is, how do I optimize for what's needed for the job? And that column prune agent is another optimization agent. It's looking at whatever comes back as columns and says, okay, I'm going to choose the columns that don't seem relevant to whatever the user is looking for. And here's an example. So it shows prune schema. It chooses the columns only that is needed. And then it mentions, if you see here, let me see. And it mentions here that certain columns are not directly relevant to the question asked. So it takes a decision that is going to take off these columns. So that shrinks whatever we send to the large language model to generate the SQL query. And now we are not hitting those token limits. So literally it's an optimization agent. And they mentioned here that the win is not only in the token size and how much the cost of the LLM call, but it actually was because the input is smaller, that means the response was faster. So now we come to evaluation. And for evaluation, they made sure that they have a golden set. In other words, we have prompts that came from customers from using QueryGPT. And then we saw what the data schemas that got generated, what was the intent that got generated, and they manually actually go through these examples and make sure they got the golden answer, which is the SQL query that gets you the right results. And depending on that, they started evaluating others. And I think they had like a couple of processes here. So from the questions that they tried to actually signal if something is working and positively impacting the tool or negatively is if the table agent that has that human in the loop component, it scores between 0 and 1. So if, for example, it guesses that there is 2 tables that has to be involved in a certain query, but the guess, depending on the human in the loop, that one table is correct and the one is not, so they score it as 50%. Or one of the other tests that they do to see if a query runs successfully as a metric. So the example that they have right here is, since large language models hallucinate, that it could infer that the status equals finished instead of status equals completed. So that's wrong, and that means that the query could run successfully but with no output. So in other words, successfully in this evaluation means I'm returning more than 0 records. And then they have the qualitative query similarity, which is the idea of comparing what the system of multiple agents that they have, does it generate something very relative to the golden SQL, which is the one that they manually put into a data set to be their evaluation set. And now we get to the limitations right here, which, because it's using large language models and the nature of it being non-deterministic, that means that right or wrong, or could be always right, but the version of a query of a SQL query could be different to answer the same question. So that's something that is always needs to be evaluated. And I like this, like last paragraph, which just says there is not always one correct answer. Often the same question could be answered by querying different tables or writing queries in different styles. By visualizing the golden versus return return SQL and using the LLM-based evaluation score, we can understand if the generated query is written in a different style but has a similar intent related to the goal in SQL. And then they go through what we just mentioned before, which is LLMs are excellent classifiers. The LLMs are really great at categorizing things. One very interesting one here on LLMs are excellent classifiers, that the intent agent, table agent, and column prune agent. And we talked about that, how the intent agent and column prune agent mainly are optimization agents. Table agent is actually deciding, depending on certain categorization, which tables are the ones that they will choose to actually do the work. But what they mention here is very important, which is they did an excellent job, those agents, because they were asked to work on a single unit of work rather than a broad generalized task. Hallucinations, of course. Another one is user prompts are not always context rich. This is very vital, because now, and again, like we sometimes, like I'm sure you heard it before, but the idea that a lot of people are used to keywording for search engines like Google. So keywording is going to get you, because we took some time actually, since like Google took over the whole search engine business, we took some time to learn how to get the most out of it. But now, with large language models in the picture, now there is a different method to talk to these large language models. And I think part of it, whether it's making sure that you direct it in the right way to actually get the best results, to provide the best context, to make sure that you don't generalize a lot. So they mention here, solely relying on user questions as good input to the LLM caused issues with accuracy and reliability. A prompt enhancer or a prompt expander was needed to massage the user question into a more context-rich question before we send those to the LLM. How do you do that from a system perspective? An example of that could be, I'm looking like, how can I build a kite? And that could be enough from the user. But what they mentioned about like prompt expander, prompt enhancer, is that behind the scenes, if I don't want to depend on the user to actually do this, is to make sure you provide a role for that LLM. Like, you're a kite builder with 20 years of experience, and you know that it's always made of plastic and nylon, and make sure that it's as light as half a pound, and etc., etc., etc. So you give all this context that enhances the prompt before you pass it to a large language model, so it can actually focus on the most valuable results with the highest probability. Yeah, so they mention here also that the type of personas that you should be testing some large language model solution should be specific, because if you're dealing with people that are highly professional with SQL and they know what they're doing, they're going to expect very, very, very high quality and a high bar for the output that comes out. But going back to the idea of LLMs hallucinating and making sure that it's always evaluated and putting a human in the loop, also, that means that you need a different type of persona that is willing to actually benefit and you see the value in such a thing as it evolves. Yeah, and that's it. That was really fun. Yeah, so overall, this paper shows us that a very good example of multi-agents working together to actually accomplish a certain task. And as we said, the idea of going from one language to another is such a fit of a scenario for large language models. Say, like, I want my natural language to turn into a declarative language like SQL, so I can fetch a certain data set. So that was a very cool example, and I think I'm going to try it out. And once I do, definitely will post something online. Thank you so much.
For Rabea Innovations.